Okay, so here is section 5.1.3. And I have to say from the outset, by now, if you are like me, you don't really like fractions a whole lot. They don't always make sense, and sometimes you really have to put some numbers in to actually convince yourself of the rules of fractions and relationships, because they are relationships. They are not equivalencies necessarily. So here we go. The big if on the left here. If A relates to B the same way that C relates to D. And again, if you're interested in thinking about this with numbers, if 2 relates to 3 the same way that, how did I want to do this? 2 relates to 3 the same way that 6, let's say, relates to 9, right? That's a true statement. The first thing that we have up here, number 1, then B relates to A the way that C, well, that shouldn't say that. That should actually say D relates to C. So let's make that change right here. Why not, right? Let's put this in, change the video a little bit, and say that that's not right. B relates to A the same way that D relates to C, right? And that can go right back to what we did over here, right? Shouldn't it make sense that if 2 relates to 3, the same way that 6 relates to 9, certainly 3 relates to 2 the same way that 9 relates to 6, right? And that's an example of what's going on there. In some ways, we've already covered number 2, that we can take this directly from here, right? That we cross multiply. A times D will definitely equal C times B. Gosh, I'm glad that one was good. Well, let's see this one. This one's a little bit funnier. Here we go, down below. Let's change these colors up a little bit, pink. Look at this one. A relates to C. So what's back in our other situation? We can say that does 2 relate to 6 the same way that 3 relates to 9? Absolutely, right? Both are 1/3. So yes, that one works, right? So we can switch. What does that say? We can bring the denominator, and put the numerator from here in the denominator on the other side, and switch them up so that B comes up here as well. It's a really funny one. This last one, these last two, if I take a look at these, then A plus B over B is equal to C plus D over D. The one way that I like to think about this one is, remember that if I unclip these, right, I actually have A over B plus B over B, because the rules of fractions mean that I carry the denominator along. C over D plus D over D. And we know right away that this is essentially 1, and this is 1. So in some ways we are taking the original equivalent statement, A over B equals C over D, and we're simply adding 1 to both sides. What it manifests itself as is being able to add the denominator into each of the tops, and that we maintain equivalency, right? This is what we're saying. These are all equivalent. This last one here, again, let's put in the numbers, and let's change up to maybe green and say, remember, this says 2 relates to 3 somehow in such a way that 2 plus 6 relates to 3 plus 9. Is that true? Well, what's the top end up being? This is 8. This is 12. All right, and there we go. The relationship is preserved. 2 relates to 3 the same way that 8 relates to 12, right? They both are divisible by 4, right? This can turn into a 2. This turns into a 3. both divisible by 4. Okay, so these are pretty much to be memorized and played with rather than fully understood. Don't worry about memorizing them. This one up here you'll use a whole lot. This one may end up using a whole lot where we reverse. These last three are a little bit more remote, but we do need them for some of our proofs along the way, and I'll remind you of those as we go.